If you are listening to this, perhaps you are somewhere quiet. Perhaps you are looking out of a window into the dark, or perhaps you are lying down preparing for rest. And perhaps, like so many billion people before you, your gaze has drifted upward toward the night sky. There is a feeling that comes with that gaze, a quiet, gentle pull, a sense of smallness, but also a sense of wonder. We look up at the pinpricks of light in the velvet darkness, and a part of us feels a call from the great silent expanse, the call of the void. For as long as we have been human, we have looked up. We have told stories about the patterns in the stars. We have navigated our oceans by their light. We have built temples to mark their movement. But in the modern world, it is easy to forget. Our own lights have blocked out the stars. Our lives are busy, filled with noise and distraction, all pointed downward at our screens, at our work, at the pavement beneath our feet. It takes a deliberate choice to stop, to go outside on a clear night away from the city, glow, and just look. When you do, the first thing that strikes you is the scale, the sheer terrifying, beautiful size of it all. And the second thing that might strike you is the strangeness. Isn't it a strange thing, a wonderful and bizarre thing that we can talk about this at all? Think about the immensity of existence. The cold dust swirling between stars, the silent orbits of frozen planets, the fiery nuclear hearts of suns. For billions of years, the universe expanded and cooled and evolved in a profound, magnificent silence with no one and nothing there to witness it. The universe did not know it was beautiful, did not know it was vast, it simply was. And then on this small blue-white pebble of rock underwater orbiting an average star in a quiet corner of a galaxy, matter did something extraordinary. After billions of years of simple chemistry, it woke up. It began to see, it began to wonder. You are the result of that process. You are not just a collection of atoms. You are a collection of atoms that can think about atoms. You are the cosmos becoming conscious of itself. The simple act of you right now thinking about the stars is one of the most profound and rare events in the known universe. We are the part of the cosmos that looks back. This awareness, this consciousness brings with it a specific powerful impulse. It is an itch in the back of the mind. We call it curiosity, we call it a desire for meaning. But at its core, it is a deep fundamental need to understand. Why are we here? What is this place? And are we alone? This is the drive that defines us. It is the engine of our species. Our journey into the cosmos was never just about technology. It was never just about rockets or politics or gaining an advantage. Those were the mechanics of it. But the reason, the why, is so much deeper. It is the voice that whispers what is over that hill. This is not a new desire. It is the same drive that pushed our earliest ancestors out of the cave to see what was in the next valley. It is the same drive that led Polynesian navigators to cross thousands of miles of open ocean in wooden canoes, with only the stars to guide them, searching for islands they were not even sure existed. We must know what is on the other side, and inevitably that drive turned our eyes to the nearest, brightest, most mysterious object in our night sky, the moon. It hung there generation after generation, a silent companion. It pulled our tides, it marked our months, and it dared us to come. For thousands of years we looked at it, we dreamed of it, we wrote poems about it, and then in a blink of cosmic time we built a machine to carry us there. Getting to the moon was not just a technological achievement, it was an inevitability. It was the next step for a species that is defined by its curiosity. It was the first tentative step of that conscious matter stepping off the shore of its island home to finally dip a toe in the vast cosmic ocean. Imagine for a moment what that must feel like, the journey up. It begins with fire and noise, a controlled explosion, a terrible, powerful shaking as the engines fight against the crushing pull of gravity pushing this tiny, fragile capsule faster and faster up through the air. But then, the fight ends, the engines cut off, and the violence is replaced by silence. A perfect, profound quiet that we can never truly experience on Earth. There is no air to carry sound, there is no up or down. You are no longer being held down, you are floating, you are weightless. This is the void. It is not empty, it is just quiet. It is the gentle drift of leaving the atmosphere. The bright, familiar blue of the sky fades to indigo, and then to a perfect velvet black. A black unlike any night you have ever seen, studded with stars that do not twinkle, for there is no air to make them dance. And it is here in this impossible quiet, floating weightless in the dark, that astronauts experience something that changes them forever. They unbuckle, they drift to the window, they look back. They look at their home. It is called the overview effect. It is a profound psychological soul shift. A cognitive realignment that happens when a human being sees the Earth not as a map, not as a collection of countries or a globe in a classroom, but as a thing, a single beautiful fragile object hanging in the void. They describe it as a blue marble, a delicate sphere of swirling white clouds, brown continents, and the deep impossible blue of the ocean, all of it hanging against the stark infinite blackness of space. From that distance, all the divisions that seem so important on the ground vanish. There are no borders, there are no lines drawn on the land, there is no sign of the noise, the conflict, the struggles. There is only this one unified living system. You can, as many astronauts have said, cover the entire human experience, every war ever fought, every song ever sung, every person you have ever loved with your thumb. It is a feeling of awe, certainly, but it is more than that. It is a sudden, overwhelming feeling of connection, a deep cellular understanding that everything and everyone is connected, that this small, fragile ball is our only home. It is, as many have said, a deeply spiritual experience regardless of one's beliefs. It is the universe showing us our own reflection, showing us our home as it truly is. We do not need to ride a rocket to feel a shadow of this. We can feel it right now in the quiet of our own space. When you look up at the stars and feel that sense of wonder that is the beginning of the overview effect, when you feel a connection to the vastness that is the echo of the astronaut's revelation, it is the call of the void. It is the universe inviting us to understand our place within it. So as we begin our journey together tonight, let that feeling wash over you. The quiet awe of the night sky, the gentle pull of the unknown. Let your mind drift. Let it float free from the gravity of your day. We are just beginning, and there is so much to see. We spend so much time looking outward, dreaming and of distant stars and galaxies that are almost too far to imagine. But there is a different kind of dream much closer to home. It glows like a quiet red ember in our night sky, a world that has fascinated us for all of history. We call it Mars, our neighbour. For so long, Mars was just a point of light, a character in our stories of science fiction. It was a place of mystery, perhaps even of strange civilizations. We sent telescopes, then satellites, and then we sent our first robotic explorers. We moved from just looking to exploring. We touched the soil, we tasted the air, and now a new idea is beginning to form. It is the transition from exploration to a much heavier word, settlement. The question is no longer just what is Mars like. The question has become, or can we stay? This is where the dream meets the reality. Mars is not a gentle invitation. It is perhaps the greatest challenge humanity has ever considered. It is a test, and more than that, it is a mirror. When we look at Mars, honestly, we see a world that is deeply, profoundly unfriendly to life as we know it. We dream of planting gardens, but Mars is the desert on a scale we can barely comprehend. It is cold, an aching deep cold that makes our own Arctic region seem warm. The average temperature is far, far below freezing. We dream of breathing the air, but Mars barely has any. The atmosphere is thin, less than 1% of Earth's. It is almost all carbon dioxide, a gas we cannot breathe. It offers no protection, no warmth. Because the planet lost its global magnetic field billions of years ago, the surface is constantly washed in radiation from the sun and from deep space. There is no shield to keep us safe, and yet we cannot look away. The beauty of Mars is a severe and silent one. Imagine standing on that red dusty plain. The ground is iron-rich sand, the colour of rust. The sky above you is not blue. Because of the fine dust hanging in the thin atmosphere, the sky is a pale salmon pink or sometimes a hazy yellow-brown. The sun would look small and weak. Sunsets are the opposite of ours. Here the setting sun paints our sky red. On Mars, the setting sun paints the sky a faint dusty blue. Sometimes the wind picks up, but this is not like an earthly storm. On Mars, there is no rain, no thunder, no smell of ozone. There is only the wind, which can grow into massive planet-wide dust storms. These storms are quiet because the air is too thin to carry sound the way we are used to. They are great swirling clouds of dust that can cover the entire planet for weeks, blocking out the weak sun completely. And in the quiet periods, the landscape is staggering. There is a mountain called Olympus Mons. It is a shield volcano so vast that if you stood at its base, you would not even know you were on a mountain. Its base would cover an entire country. It rises so high that its peak pokes out above the thin atmosphere. It is a monument to a time when Mars was geologically alive, a time now long past. It is a giant sleeping in lonely majesty. We are already there in a way. We have sent our extensions, our robotic children. The rovers, curiosity, perseverance, and the memory of spirit and opportunity. They creep across the ancient dry riverbeds and craters. They are the picture of patience. They drill into rocks, they analyze the soil, they listen for the whisper of the wind. They send us back photographs of endless rockfields and dusty hills. And in their silence, as they wait for their next command from a world millions of miles away, they seem to be waiting for the soft footsteps of their creators, waiting for us. This brings us back to the question, can we stay? This is the great test. Because Mars is not an escape. If we are looking for a new Earth, because we have damaged our own, Mars will not save us. It is too hard, too demanding. It will take all of our technology, all of our courage, and all of our resources just to keep a few people alive inside a small protected dome. Mars is not Earth 2, Mars is a mirror. When we look at Mars, we are forced to see ourselves. We see a world that might have had life billions of years ago. It had rivers, it had lakes, it may have had an ocean, it was warmer, wetter, and it lost it all. When we look at that dry, cold, irradiated surface, we see a planet without a beating heart, without an ocean, without a thick, protective sky. And in that sharp red reflection, we must finally see Earth. We see the impossible, fragile miracle of our own home. We see a world bursting with life covered in liquid water, wrapped in a perfect blanket of air, protected by a magnetic field, all balanced in a delicate dance. A dance we are now disrupting. This is the true meaning of becoming a multiplanetary species. The goal of going to Mars is not to abandon Earth. The goal is to learn. By facing the challenge of building a small artificial biosphere on Mars, where every drop of water must be recycled, every breath of air must be generated, and all waste must be reused, we will finally learn how to be truly sustainable. To survive on Mars, we must become masters of engineering life. We must learn how to protect the air, the water, and the biology that keeps us alive. Mars, in its sterile emptiness, forces us to appreciate the complex living system we already have. It teaches us that a planet is a precious, delicate thing. So as we dream of those pink skies and the silent red sand, as we imagine the lonely vigil of the rovers waiting for us, we look at that red neighbour. It is a challenge, it is a warning, it is perhaps our most important teacher. By reaching for Mars, we are not just reaching for another world, we are reaching for the wisdom to save our own. We stand in our minds on the red dust of Mars. We look up at a faint blue dot in the sky, our Earth. We look down at the rock beneath our feet. It feels solid. It feels real. We are creatures of the middle land. We are perfectly scaled to understand things like rocks and oceans and planets. Our brains evolved to predict the arc of a spear, the path of a river, the rising of the sun. This is the world Isaac Newton described. A world of cause and effect. A predictable, reliable, comfortable machine. If you push something, it moves. We call this classical physics. And for almost all of human history, we thought that was the end of the story. We thought reality was just a bigger version of what we could see. We assumed that if we just zoomed in far enough, a rock would be made of smaller rocks, and those smaller rocks would be made of even smaller rocks. We assumed the universe at its smallest level would behave just like a tiny, tiny billiard ball. We were wrong. As we leave the comfortable classical world of Mars and the planets, we must journey somewhere else. We must zoom in. We dive through the red iron oxide dust, past the lattices of molecules, deep into the heart of a single atom. We push past the orbiting electron cloud and we arrive at the center of the nucleus. We have now entered a place where none of our human intuition works. Welcome to the quantum realm, and the first thing you notice down here is the slipperiness. Nothing is solid, nothing is fixed. The hard, predictable rules of Newton dissolve. In the quantum world, things are not things in the way we understand them. They are potentials, they are probabilities. This is the home of the most famous and baffling idea in all of science superposition. Let's try an experiment. In our classical world, if I throw a baseball at a wall with two windows, the ball goes through one window or the other window. It cannot go through both. It is a particle. It has a definite location. Now let's do it in the quantum realm. Our ball is a single electron. Our wall is a barrier with two tiny slits. We fire one electron at the barrier. Where does it land? If the electron is a tiny ball, it should go through the left slit or the right slit and create two simple clumps of hits on the detector screen behind it. But that is not what happens. When we fire the electrons one by one, they don't create two clumps. They create a pattern of many lines like the ripples in a pond when you drop in two pebbles at once. It's an interference pattern. The only possible way to get that pattern is if the electron didn't go through one slit or the other. It behaved like a wave and went through both slits at the same time. Think about that. The fundamental building block of that rock on Mars, when we aren't looking at it, isn't in one single place. It is smeared out in a wave of all possibilities. It is here and there and a little bit over there all at once. This being in many states at once is called superposition. This isn't just a fun theory, it's the technology driving our future. A normal computer bit is a 0 or a 1. A qubit, a quantum bit, uses superposition to be a 0 and a 1 at the exact same time. It's this ability to explore millions of possibilities at once that promises a revolution in computing. But this leads to an even more disturbing question. If an electron is a wave of all possibilities when we aren't looking, why does it look like a fixed particle when we do look? This is the great mystery of quantum mechanics. The moment we try to measure which slit the electron went through, the experiment breaks, the interference pattern vanishes, the electron suddenly picks a side and it goes back to behaving like a simple baseball. The very act of observing reality seems to change it. This led physicists to a startling conclusion. Reality at its base is not fixed. It is probabilistic. The universe at its most fundamental level is just a shimmering sea of potential. It only collapses into a definite state, this rock, that, planet, you, me, when an observation is made. It means that the universe is not a static stage where the play of life happens. The universe itself is being written moment by the very act of participation. But the rabbit hole goes deeper. If this is true, what happens if you link two particles together and then separate them? This is quantum entanglement. Imagine you have two electrons. You create them in a special way so that they are linked. They are now part of a single quantum system. Let's say their spin. You can think of it like a tiny magnet must be opposite. If one is spin up, the other must be spin down. But because of superposition, neither particle has a fixed spin yet. They are both in a state of spin up and spin down. Now we take one of these electrons and leave it here on Earth. We put the other one on a rocket and send it to our friend on Mars. They are now millions of miles apart. Back on Earth, you decide to measure your particle. The wave of possibilities collapses. Your particle chooses its state. Let's say it becomes spin up. Here is the mystery. The instant faster than the speed of light that your particle becomes spin up, the particle on Mars, millions of miles away, instantly becomes spin down. Your measurement on Earth immediately affected the reality of a particle on Mars. This is what Albert Einstein famously hated. He called it spooky action at a distance. He was a classical thinker. He believed in a local sensible reality. He believed information could not travel faster than light. He was so disturbed by this that he argued quantum mechanics must be incomplete. But for once, Einstein was wrong. Experiment after experiment has proven it. Entanglement is real. The universe is non-local. What happens here can and does instantly affect what happens there. It tells us that at a fundamental level, those two particles are not separate things even when separated by a galaxy. They are still part of a single unified system. This brings us back to the beginning. We started with the very big, the cosmos. We dove down into the very small, the quantum. Now we must connect them. How does this spooky and slippery, probabilistic world of electrons create the massive, predictable galaxies we see in our telescopes? The answer is found in the very first moments of the universe. Go back to the Big Bang, before the stars, before atoms, and before light itself could even travel freely. The universe was a point of unimaginable density and energy. In that first fraction of a second, the entire universe was smaller than a single atom. The whole cosmos was a quantum system. It wasn't smooth, it wasn't uniform. Just like a calm ocean is actually a churning mass of bubbles at the microscopic level, the early universe was a foam. It was a bubbling, chaotic, cosmic foam of energy. And this foam was governed by quantum rules. Because of superposition energy, and particles were fluctuating, popping into and out of existence in random probabilistic ways. These were quantum fluctuations. In this foam, some spots would just by pure chance be microscopically denser than other spots. These were just tiny random quantum ripples. In our normal world, they would average out and disappear. But then something incredible happened, cosmic inflation. In a fraction of a second, the universe exploded outwards, expanding faster than the speed of light. And as it expanded, it stretched those tiny microscopic quantum fluctuations. It ballooned them up to cosmological size. Those tiny random fluctuations born from the slipperiness of quantum mechanics became the seeds of everything. Those tiny dense spots, now stretched to be light years across, had more gravity. Over the next few 100 million years, they began to pull in the first gas. That gas clumped together. It ignited. It became the first stars. Those stars gathered into the first galaxies. Those galaxies pulled on each other, clustering together along the filaments of those original fluctuations. When you look at a map of the universe today, the cosmic web of superclusters of galaxies separated by vast empty voids, you're not looking at something classical. You are looking at a snapshot. You are looking at the quantum foam from the first second of time just blown up to a scale of billions of light years. The grandest structure in the universe is a direct physical fossil of the quantum world. The rock on Mars is not separate from the rules of the electron. The rock on Mars is built from the rules of the electron. The vast silent structures of the cosmos are not just out there. They are the echoes of the spooky, probabilistic, and entangled reality that lives at the very heart of everything. We in our middle land see a solid world, but the universe has shown us the truth. Reality is not fixed, it is a possibility. Things are not separate, they are connected, and the largest things we can imagine are born from the smallest things we can barely comprehend. We are often told that science is cold. We are taught to think of it as a sterile logical process, a world of white lab coats, stainless steel, and numbers that are devoid of feeling. We imagine the scientist as a kind of robot processing data detached from the messy, emotional, vibrant experience of being human. This could not be more wrong. Science in its deepest and most honest sense is a kind of poetry. It is a profoundly human art form driven not by algorithms but by the same impulses that create a painting, a symphony, or a poem. It is the raw, unfiltered expression of our most fundamental human trait, a burning emotional curiosity about where we are and what we are. We look for beauty in the world, and science is simply the most rigorous tool we have invented for finding it. We are told that equations are cold, but to a physicist, a powerful equation is a revelation. It is a sentence written in the native language of the universe that exposes a deep and unexpected truth. Equations can make you feel something. When you truly understand a simple equation like energy equals mass times the speed of light squared, you are not just looking at symbols. You are witnessing the fundamental unity of the cosmos. You are feeling the stunning realization that the energy in starlight and the solid matter beneath your feet are made of the same essential stuff, just wearing different masks. That feeling is not cold, it is awe. When James Clerk Maxwell wrote down his 4 elegant equations in the 19th century, he wasn't just doing math. He was, perhaps without even knowing it at first, writing a poem that unified the universe. He took 2 things that seemed completely separate, electricity and magnetism, and wove them together. In doing so, his equations predicted something. They predicted that a wave of this unified force must travel at a specific constant speed. When he calculated that speed, he found it was the exact measured speed of light. Imagine that moment. It is the instant a human mind realized that light itself, the sunshine on your face, the light from distant stars, is a wave of electricity and magnetism. That is not a calculation, that is a symphony. It is the universe revealing one of its greatest secrets. This poetry is written everywhere. The universe is not a chaotic accident, it is built on rhythm. We see it in the grand sweeping motions of the cosmos. There is a rhythm to the faithful orbit of the Earth around the Sun, a predictable pulse that gives us our seasons, our years, and our very concept of time. There is a rhythm in the predictable tides pulled by the moon, a constant breathing of the oceans. But the rhythm is also written in the smallest parts of us. The most intimate poem of all is the one found inside every one of your cells, the double helix of your DNA, your deoxyribonucleic acid. This is not a random string of chemicals. It is a text. It is a set of instructions, an epic poem written over 3 billion years telling the story of survival, adaptation, and life. The spiral staircase of DNA is a shape of profound beauty, a physical structure that carries the entire legacy of our species. It is the rhythm of life itself. If nature is the poem, then scientists are its translators. They are the poets with numbers. We mistake their precision for a lack of passion. In truth, their precision is the source of their passion. A scientist is not a person who knows all the answers. A scientist is a person who is comfortable being lost, who is driven by the emotion of not knowing. The life of a scientist is not a steady march toward truth. It is a human story. It is a story of long dark nights, of frustration, of experiments that fail, of calculations that lead nowhere. It is a story of doubt and confusion. And then sometimes there is a moment of clarity. A pattern emerges from the noise. A single data point changes everything. In that moment, the scientist feels a sudden breathtaking wave of understanding. It is a feeling of joy, of relief, of a profound and personal connection to the cosmos. That eureka moment is one of the most powerful emotional experiences a human being can have. It is the feeling of having touched a fundamental truth. To see this humanity in action, we only need to look at one of the greatest discoveries of all time. It is a story that does not begin with a grand theory, but with a simple, annoying sound. The story begins in 1964 at Bell Labs in New Jersey. Two young radio astronomers, Arno Penzias and Robert Wilson, were given a new tool, a massive horn-shaped antenna 60 feet long, originally built for satellite communication. Their job was to use this incredibly sensitive antenna to map the faint radio signals from the edges of our Milky Way galaxy. But they had a problem. From the moment they turned it on, they heard a hiss. It was a persistent, steady, low-level noise that they could not get rid of. It was like the static on an old television, a sound that seemed to come from everywhere and nowhere. This noise was a contaminant. It was ruining their data. They had to find its source. So they did what any good scientist or any good repairman would do. They began troubleshooting. They thought at first that the noise must be human-made. They pointed the antenna directly at New York City. The hiss was there. They pointed it at an empty patch of sky. The hiss was still there. It didn't change with the time of day. It didn't change with the seasons. It was constant. They checked the wiring. They rechecked the amplifiers. They rebuilt parts of the system. The hiss remained. Then they found a likely culprit. A pair of pigeons had been nesting in the warm horn-shaped antenna. The scientists trapped the pigeons and drove them miles away. The pigeons, being pigeons, were back the next day. Penzias and Wilson finally and famously climbed into the antenna themselves. They found what they called a white dielectric material, a polite scientific term for bird droppings. They meticulously cleaned the entire antenna, believing this was surely the source of the thermal noise. They turned the antenna back on. The hiss was still there. They were frustrated. This noise was a failure. It was an imperfection in their perfect instrument. But as they continued to measure it, they discovered something profound. This hiss was not coming from New York. It was not coming from the pigeons. It was not coming from our solar system or even from our galaxy. It was coming from every single direction in the sky at the same time with the same intensity. The noise wasn't in the antenna, the noise was the universe. At the same time, just a few miles away at Princeton University, a team of physicists led by Robert Dicke was working on a theory. They believed that if the universe had begun with a Big Bang, a hot, dense explosion, then the incredible blinding light from that creation event must still be here. It would have cooled over billions of years, stretching out as the universe expanded. It would no longer be visible light. It would be a cold, faint glow, a microwave signal with a temperature just a few degrees above absolute zero. Dicke and his team were building an antenna to go looking for this exact signal. They were trying to find the heat left over from the Big Bang. Penzias and Wilson, unaware of this, made a phone call. They described their mysterious, unavoidable uniform hiss to the Princeton team. The story goes that after the call, Robert Dicke turned to his colleagues in the room and said, "Boys, we've been scooped," and Penzias and Wilson had stumbled upon the echo of creation. Stop and think about that feeling. Put yourself in their shoes. That annoying static, that noise you tried to scrub away, it was the oldest sound in history. It was the afterglow of the Big Bang, the residual heat from the birth of the entire cosmos washing over the Earth from every direction. They were listening to the first light in the universe, a fossil from 14 billion years ago. This discovery was not a cold calculation. It was a human story of frustration, confusion, and pigeons, but its conclusion is the most poetic imaginable. The moment of realization, the moment Penzias and Wilson understood what they were hearing, is an emotion that transcends logic. It is a feeling of awe so profound it borders on fear. It is the realization that the cosmos had a beginning and we on our tiny blue planet had just heard its voice. That is science. Science is not the enemy of wonder, it is its greatest catalyst. It does not diminish the beauty of a star by explaining it. It enhances it by showing us the nuclear furnace raging within the unfathomable distances, the fact that the iron in our own blood was forged in the heart of a dying star just like it. Science is the ultimate expression of our humanity. It is our refusal to accept the world as it appears. It is our willingness to be wrong, to be humble, to be patient, and to look closer. It is a search for beauty, a search for truth, and a search for our connection to everything else. The equations are the verses, the natural world is the text, and the discoveries, those moments of sudden emotional clarity, are the punctuation. Science is the greatest poem. We are collectively writing a story that tells us who we are and where we belong in this vast, rhythmic and beautiful cosmos. For so long we stood on our small world and looked up drawing lines between the lights, telling stories about gods and heroes. We placed ourselves at the very middle of everything. It was a comfortable thought, a story that made us feel important. But the universe is a patient teacher, and slowly, gently, it has been revealing a very different story. How did we ever imagine we were the center? When we look out now, we understand that every point of light is not just a light. It is a sun, a distant burning star perhaps with worlds of its own just like ours. This realization was staggering. It took our small cozy home and placed it in a crowd of billions. But the universe was not finished showing us our place. It had one more even greater lesson in perspective. It asked us to look even deeper past the individual stars. It pointed to the faint milky band of light that stretches across our own night sky, a river of light our ancestors named the Milky Way. For millennia we thought it was just a cloud, a celestial river. Now we know the truth. We are not just looking at it, we are inside it. That faint beautiful glow is the combined light of billions of stars so far away that our eyes blend them into a soft brushstroke. This is our home. We live inside a galaxy. Imagine for a moment that we could travel outside of it impossibly far and look back. What would we see? We would not see a random cluster of stars. We would see one of the most beautiful structures in the cosmos, a vast spinning spiral, a pinwheel of light and dust 100,000 light years across. It has graceful sweeping arms, twisting out from a bright dense center. This is the Milky Way, a peaceful island universe. And where are we? We are not in the chaotic, brilliant center where a supermassive black hole, a sleeping giant named Sagittarius A star, quietly holds everything together. We are not in the empty dark regions far beyond the arms. We are here in a quiet suburb. We live on a small planet orbiting an average sun tucked away in a calm partial arm called the Orion Spur. We are in the galactic equivalent of a quiet countryside far from the bustling core. We are safe here. We are in a cosmic sense wonderfully and profoundly average. Our galaxy is home to perhaps 400 billion stars, 400 billion suns. Many of them we now know have planets. Think of the numbers, think of the sheer potential. Our sun is just one of billions, and our galaxy is just one of billions. This is the next great step in our cosmic address. Just as our sun is not alone, our galaxy is not alone. It too has a family. We are part of a small intimate collection of galaxies called the local group. It is our celestial neighborhood. The Milky Way is one of the two big residents. The other is a magnificent larger spiral, the Andromeda Galaxy. It is our closest major neighbor, a stunning island of stars just 2.5 million light years away. It is so close in fact that on a very clear dark night you can just barely see it with your naked eye. It looks like a faint blurry smudge of light. That smudge is a galaxy. It is another pinwheel of hundreds of billions of stars. When you look at it, you are looking at the most distant object you will ever see without a telescope. You are looking across millions of years of time and space. And here in this quiet neighborhood, we are not static, we are not still. The user's sense of drift is profoundly correct, and everything in our local group is bound together by gravity. We are all moving, dancing around a common center. And the most dramatic dance partner we have is Andromeda. It is moving towards us. Right now, the Andromeda Galaxy is approaching the Milky Way at a speed of over 100 kilometers every second. There is no need for panic. This is not a catastrophe. This is creation. In about 4.5 billion years, our two great spiral galaxies will meet. They will not collide in the way two solid objects do. Stars are too far apart for that. Instead, they will pass through each other like two ghosts. Gravity will stretch and pull them. They will swing apart, then be pulled back together again. Over hundreds of millions of years, they will merge. Their spiral arms will be torn apart, their stars flung into new orbits until finally they settle into a single enormous new galaxy. A giant elliptical galaxy. Our solar system will likely be thrown into a completely different part of this new combined home. The night sky our descendants, see if any are here, will be utterly transformed. This is our future, a slow, majestic gravitational merger. And what lies beyond our local group? What is outside our quiet neighborhood? Here we encounter the true meaning of emptiness, the great silence. The universe is not a uniform sea of galaxies. It is structured. It is a cosmic web. Imagine vast empty regions of space almost perfectly black called voids. These are the great deserts of the cosmos, hundreds of millions of light years across, containing almost nothing. And stretching between these voids are long, thin strings of matter, like the threads of a spider's web. These are the filaments. And on these filaments, galaxies are strung like pearls. Where the filaments cross, you find massive clusters, cosmic cities with thousands of galaxies all clustered together. Our local group is just one tiny collection on one small filament on the edge of a giant void. We are adrift in an ocean of darkness connected to everything else by the faintest, most ancient threads of gravity. So we return to our question. How did we ever imagine we were the center? We're on a small planet orbiting one star among 400 billion in a quiet arm of a spiral galaxy. This galaxy is one of dozens in a small local group. This group is drifting on the edge of a great cosmic supercluster separated from other clusters by a silence so vast it is almost impossible to comprehend. We are not the center. We are perhaps the very definition of the periphery, and yet from this small, quiet, faraway place we have done something remarkable. We have looked up, we have learned the story, we have figured out our address. We, a collection of atoms forged in the hearts of long-dead stars, have become conscious. We are the universe looking back at itself, and that perhaps makes this quiet, small place the most important place of all. We have spent our time together looking outward. We have spanned the incomprehensible distances between galaxies and traveled across the deep, dark oceans of time. We've witnessed the birth of structure and the slow, grand dance of gravity. But now I want to bring our focus home. I want you to stop just for a moment looking up at the theoretical night sky. Instead, I want you to look down. Look at your own hand. Look at the skin, the bones beneath it, the blood flowing silently within it. You are not just an observer of the universe, you are the universe. There is a famous saying, "We are the universe becoming aware of itself." This is not just a beautiful piece of poetry, so it is perhaps the most profound and literal scientific truth we have ever discovered. To understand why, we have to ask a simple question. Where did the stuff that makes you come from? When the universe began in the Big Bang nearly 14 billion years ago, the only elements that existed were the simplest, lightest ones. The cosmos was almost entirely hydrogen and helium with a tiny, tiny amount of lithium. But look at yourself. Your body is a symphony of complex chemistry. You are built from carbon. You breathe oxygen. Your muscles are powered by potassium and sodium. Your bones are structured with calcium. Your blood, the very liquid that carries life through your veins, has iron at its core. None of these elements existed at the beginning. They had to be made. They were not made on Earth. They were made in the sky. They were cooked, forged, and perfected inside the hearts of stars. Every star you see, including our own sun, is a gigantic factory. It is a factory for making heavier elements. We call this process stellar nucleosynthesis, which is just a scientific way of saying making new things inside a star. It all starts with gravity. Gravity pulls a massive cloud of that original hydrogen gas together. It squeezes it tighter and tighter until the pressure and temperature at the center of the cloud become unimaginable millions of degrees. At this point, the hydrogen atoms are moving so fast that they overcome their natural repulsion and slam into each other. They fuse. In this fiery process, hydrogen atoms join together to create a new heavier element, helium. This fusion releases a tremendous amount of energy. It is the energy that pushes outward, balancing the crush of gravity and allowing the star to be stable for billions of years. It is the energy we see as sunlight. Our sun is doing this right now. It is turning hydrogen into helium. But our sun is a relatively small star. In stars that are much, much more massive, the process doesn't stop there. When a massive star uses up the hydrogen in its core, gravity squeezes it again. The core gets even hotter until it's hot enough to start fusing the helium it just made. The helium atoms slam together to create carbon. And then the star becomes like a giant onion. When the helium runs out, the core contracts and heats up again. It starts fusing carbon into oxygen. It fuses oxygen into neon, then magnesium silicon, and so on, building heavier and heavier elements in layers. But this process has a limit. It stops at one specific element, iron. Iron N is special. It is the most stable element in the universe. When a star fuses elements lighter than iron, it releases energy. But if you try to fuse iron into something heavier, it doesn't release energy. It consumes it. For a massive star, creating iron in its core is a death sentence. The star's engine, the fusion that has held it up for millions of years, suddenly stops. The outward pushing energy vanishes. In an instant, gravity wins. The star collapses on itself with catastrophic speed. The outer layers rush inward at a quarter of the speed of light. This collapse triggers an explosion so violent it beggars description. It is a supernova. A single supernova can briefly outshine its entire galaxy. In that final fiery moment, the energy is so intense that it does what the star's core never could. It forces atoms together to create all the elements heavier than iron. The silver in your jewelry, the gold in a vault, the uranium that powers our reactors. All of it was born in the final dying scream of a star. This explosion is the universe's most vital act of recycling. The star dies, but in its death it seeds the cosmos. It blasts all those new elements, the carbon, the oxygen, the iron, the gold, out into space, scattering them across billions of miles. This scattered material is what we call stardust. Billions of years ago, in our corner of the Milky Way, a cloud of this recycled stardust began to gather. It was a cloud enriched by the ghosts of stars that had lived and died long before. Gravity pulled this dust and gas together. At the centre, a new star was born, our Sun, and from the leftover disk of dust and debris the planets formed, including our Earth. This is our cosmic origin. This is why Earth is a statistical miracle. It's not just a rock. It is a collection of recycled second-hand star stuff placed at the perfect distance from its new star. So look at your hand one more time. The calcium giving your bones their strength was forged inside a star more than 5 billion years ago. The iron in your blood, the atom that allows you to carry oxygen to your brain, was created in the heart of a supernova. The carbon that forms the basis of your DNA, the blueprint of your entire life, was fused from helium in a red giant. You are not just living on the Earth. You are the Earth. You are the stardust. You are the atoms from those ancient exploded stars. You are the universe gathered together for a short precious time, finally able to look back out at the sky and wonder where it all came from. We have traced our lineage back to the stars. We learned that we are made of hydrogen, carbon, and oxygen, all forged in the fiery hearts of dying suns. This knowledge, this grand story of our origin, is not the property of one nation, one tribe, or one philosophy. It is the shared inheritance of all humanity. Science, in this sense, has become our only truly universal language. It is a language that does not care about our flags or our borders. The law of gravity works the same in every country. The speed of light is a constant for everyone. This shared understanding is the most profound connection we have. It is a language that tells us we are one species living on one fragile planet floating in an impossibly vast ocean of space. But this language, this powerful tool of science, is a double-edged sword. With knowledge comes power, and power is always a source of profound tension. For every discovery that has given us the ability to build it, has also given us the ability to destroy. We learned to split the atom to create clean energy, a power source that could lift continents out of poverty. In the very same breath, we use that knowledge to create a weapon that can erase an entire city, and perhaps our entire civilization, in a single blinding flash of light. For every breakthrough that gives us the power to heal, we also find the potential to harm. We have mapped the human genome, giving us the tools to cure genetic diseases that have plagued us for millennia. Yet this same knowledge whispers of the power to manipulate, to control, to decide who is worthy of life, and what that life should look like. This is the great paradox of our modern age. We are a species that can analyze the chemical composition of an atmosphere on a planet orbiting a distant star, but we still struggle to manage the conflicts in our own homes and between our own borders. We have built technologies of immense, almost godlike complexity, yet we often behave with the same tribal, short-sighted instincts that guided us on the ancient savannas. This leads us to the single most important question of our time, the question that hangs over every equation, every discovery, and every new piece of technology. We are clearly intelligent, but can we be wise? Intelligence is about knowing how. It's about building the faster ship, the sharper spear, the more complex computer. Wisdom is about knowing why. It's about asking, should we build this at all? Wisdom is about understanding the long-term consequences, about empathy, about restraint. Intelligence builds the fire. Wisdom prevents the fire from burning down the entire forest. Our survival's arrival as a species no longer depends on how smart we are. It depends entirely on our capacity for wisdom. And when we look for guidance, when we turn our powerful telescopes back to the cosmos that created us, we are met with a deafening, terrifying, and profound silence. Our galaxy alone contains hundreds of billions of stars. We now know that planets are common, many of them in the habitable zone where liquid water could exist. The ingredients for life, carbon, water, energy are everywhere. The universe is 13.8 billion years old. Our civilization is just a few thousand years old. Our technology is barely a century old. There should have been ample time for other civilizations to rise to master their own sciences and to spread across the stars. So where is everybody? This is the Fermi paradox. It is often called the Great Seance. This seance is not just a scientific curiosity, it is a mirror. It forces us to confront uncomfortable possibilities about our own nature and our own future. One possible answer to this silence is what scientists call the Great Filter. This is the idea that there is some barrier, some challenge that is so difficult that almost no form of life ever makes it past. Perhaps that filter is behind us. Maybe the emergence of life itself, or the leap from a single cell to a complex animal, is so statistically impossible that we are the first and only ones to have passed it. This would make us a miracle, the lone voice in the cosmic darkness. This is the argument for cosmic loneliness. If this is true, we are the sole caretakers of consciousness in the visible universe. The weight of that responsibility is almost too heavy to imagine. Every life, every poem, every act of kindness is precious beyond measure, because if we fail, the unful of us returns us to a deep sleep of mindless matter and energy. But there is a darker possibility. What if the Great Filter is not behind us? What if it is in front of us? What if the filter is the tendency of every intelligent civilization to discover the very power that will lead to its own destruction? What if the build and destroy tension is a universal test, and what if nobody passes? The silence in this scenario is the sound of failure. It is the graveyard of countless civilizations that reach the exact point we are at right consumer he moment they split the atom, the moment they began to alter their planet's climate, the moment their intelligence surpassed their wisdom. The silence is a warning shouted from the ruins of 1 billion extinct worlds. It tells us that the build and destroy conflict is the final exam of the cosmos, and the passing grade is survival. This brings our responsibility into sharp focus. Let us imagine for a moment that we do pass the test. Let us imagine we find a way to manage our power, to act with wisdom, and to survive ourselves. What happens next? What happens if we are the ones who break the silence? If we find love on another world, even simple microbial life, what is our moral duty? Do we have the right to study it, to contain it, to alter its environment? Or do we have a sacred duty to leave it alone, to watch it from a distance, allowing it to follow its own evolutionary path safe from our contamination? The question becomes infinitely more complex if the life we find is intelligent. If we are the advanced ones, do we intervene? Do we help them, risking the same cultural contamination and destruction that has marked human history, whenever a more technologically advanced society has met a less advanced one? Or what if we are the ones who are less advanced? What if a signal arrives tomorrow? This is the ultimate test of cosmic connection. Are we ready to be part of a galactic community? The answer right now is likely no. We cannot even maintain peace within our own small species on our one small world. Our quest for the stars, our study of cosmology, forces us to look in the mirror. Before we can responsibly say hello to another civilization, we must first learn how to talk to each other. Before we can presume to heal or harm another world, we must stop harming our own. The silence of the universe places the burden entirely on us. We cannot look to the stars for answers or for salvation. The answers must come from within. We are the children of the cosmos, grown up and now holding the key to our own future. Our origin story is not just a scientific epic, it is a moral challenge. We are stardust that has become self-aware. The final question is what we choose to do with that awareness. The universe is waiting for our answer. Will it be the brief, terrible flash of self-destruction? Or will it be the first note of a song that joins the empty choir? Can we be wise? We must be. We have journeyed to the edge of the observable universe and into the quantum heart of matter. We have traced the story of stardust, the evolution of life, and the search for meaning in the grand, silent cosmic cathedral. But now we arrive at the final and perhaps greatest mystery. It is not found in the blaze of a supernova or the equations of a black hole. It is found in the one place we have been looking from. We must turn our gaze inward. The real quest is not just about what we are looking at, but about the fact that we are looking at all. This simple, undeniable fact of our own awareness is without hyperbole the most extraordinary phenomenon in the universe. We can explain the physics of light, the biology of the eye, and the neurology of the brain. We can trace the path of photons, the firing of synapses, and the processing of data. But we cannot explain the feeling. We cannot explain the redness of a sunset, the sorrow of a lost love, the taste of salt on the wind, or the sound of a C major chord. This is the hard problem of consciousness. It is the simple, subjective, qualitative experience of being alive. This awareness is not a loud, brute force. It is a delicate flowering that bloomed on this small, wet planet, allowing a tiny fragment of the cosmos to wake up and for the first time know itself. For most of human history, we assumed this awareness was a gift from the gods, a soul, separate from the physical body. Then modern science offered a different, colder explanation. We were told that consciousness is just a byproduct of complexity. It is an illusion, an epiphenomenon, a ghost in the machine. In this view, the universe is a vast, mindless clockwork, and we are just spectators, biological robots who happen to have a movie playing inside our heads, a movie we cannot influence and which serves no real purpose. This view has always felt incomplete. It leaves us hollow. It makes us aliens in our own universe, a cosmic accident. But what if this model is not just depressing but fundamentally wrong? What if we have been looking at the problem from the wrong direction? A radical and ancient idea now re-emerging in modern thought is panpsychism. This is the theory that consciousness is not a late-in-the-day accident but a fundamental property of the universe right alongside gravity and electromagnetism. In this view, consciousness is not something that complex brains create out of dead matter. Instead, consciousness is woven into the very fabric of reality itself. This does not mean that rocks are thinking or that electrons are having existential crises. That is a common misunderstanding. It means rather that a primitive form of experience, a basic rudimentary spark of feeling, exists at the most fundamental level of physics. A proton doesn't think, but perhaps it feels the pull of a magnetic field. A photon doesn't see, but perhaps it has a simple subjective experience of its own existence. This is what some philosophers call proto-consciousness. By itself, this minimal awareness is almost nothing. But when these fundamental particles combine over billions of years into more and more complex structures, from atoms to molecules, from simple cells to a human brain, this proto-consciousness does not just add up. It integrates. It combines like musical notes forming a symphony until it blossoms into the rich, complex, self-aware consciousness that you and I experience right now. This idea, once dismissed as mysticism, is now being taken seriously by scientists and philosophers. They're trying to find the how. One of the most prominent theories is the Integrated Information Theory, or IIT. This theory proposes that consciousness is not about what a system is made of like neurons, but about what it does. Specifically, it measures how much integrated information a system possesses. Think of it this way. A digital camera sensor has millions of pixels. Each pixel sees a tiny bit of the world, but they don't talk to each other. The camera sensor is not aware. A human brain, however, is a network of billions of neurons, and every part is deeply interconnected with every other part. You cannot separate sight from memory from emotion. It is all one unified experience. Integrated information theory attempts to create a precise mathematical value for this unity, a number called phi. A system with a low phi, like a rock or a heap of sand, has little to no consciousness. A system with a high phi, like a human brain, has a high degree of consciousness. This theory implies that any system with integrated information has some degree of awareness. It suggests a spectrum. A mouse would have less phi than a human, a bee less than a mouse, and a thermostat perhaps a tiny, tiny fraction of one. But it is not zero. Another even more profound theory looks for the answer in the quantum world. This is the Orchestrated Objective Reduction, or OR theory, proposed by the physicist Sir Roger Penrose and the anesthesiologist Stuart Hameroff. They argue that consciousness is not a computational process that happens between neurons, but a quantum process that happens inside them. They identified tiny structures within our brain cells called microtubules. They believe these structures are like quantum computers perfectly designed to harness the strange rules of the quantum realm. In their view, our awareness is the result of a delicate quantum wave function, the same one that governs electrons and photons collapsing or reducing inside our brains. This objective reduction, Penrose argues, is a fundamental event in the universe's physics, a process connected to the very geometry of space-time. If this is true, it means our minds are not just biological computers, they are quantum antennas directly linked to the fundamental workings of the cosmos. Our thoughts are in a literal sense woven from the same quantum foam that underlies all of reality. What does this all mean for us for the journey of our lives? It means that the old cold view of us as spectators is dead. If consciousness is fundamental, then we are not just watching the cosmic movie. We are in it. We are part of it. This leads to the concept of the participatory universe. This idea, long discussed by thinkers like Deepak Chopra and rooted in the very foundations of quantum mechanics, suggests that reality is not a fixed objective thing that exists out there without us. Instead, reality is a process that requires a conscious observer. The famous observer effect in quantum physics shows that a particle like an electron does not have a definite position until we look at it. The act of observation. The act of consciousness in some mysterious way helps call reality into being. We are not just spectators, we are co-creators. We are the universe's way of looking at itself. We are the mechanism by which the cosmos becomes aware. The Big Bang was not just an explosion of matter, it was the beginning of a story that leads perhaps inevitably to a being who can look up at the stars and wonder, are the climax of that story so far? This new understanding solves the deepest human feeling of all, the feeling of alienation, of being a stranger in the universe. If panpsychism is correct, we are never and have never been alone. We are not fragile specks of life in a vast dead void. We are swimming in an ocean of awareness. The philosopher Robert Nozick beautifully captured this shift in identity. He asked us to stop thinking of ourselves as solid, separate things that exist in the universe. He suggested we should instead think of ourselves as waves. A wave, after all, is not separate from the ocean. A wave is a momentary, beautiful, complex expression of the ocean. It is the ocean itself rising up to take on a unique temporary form before it returns to the whole. You are not a lonely spectator trapped in a body. You are a wave. You are the entire conscious cosmos rising up for a brief and glorious moment to experience the world through your eyes, to feel the world through your heart, to think the world through your mind. This creates the ultimate sense of belonging. We do not just belong to Earth, we belong to the fabric of reality. Our awareness is not an isolated miracle, it is a drop of a much larger conscious ocean. When we look inward, we are not just exploring the small confined space of our own skull, we are touching the fundamental material of all existence. The great journey out there into the cosmos and the deep journey in here into consciousness are not two different paths, they are the same journey. They are two loops of a single infinite ribbon. To understand the universe, we must understand the mind that perceives it. And to truly understand ourselves, we must understand the universe that we are a part of. The search ends and begins with the simple, breathtaking realization that the observer and the observed, the mind and the cosmos are and always have been one. And so we arrive at the end of our long journey. We have travelled from the unimaginable singularity of the beginning, that single explosive point of light that contained everything. We have drifted through the eons as stars were born and as they died, scattering the dust of life across the cosmos. We have walked on the surface of a small blue planet, looked up and asked the biggest questions. Why are we here? What does it all mean? We began this search perhaps seeking answers. We are creatures who crave certainty. We want to stand on solid ground. We want the universe to provide us with a clear-cut purpose, a map with a destination marked "You are here," and a purpose labelled "This is why." But the journey through the cosmos through science and philosophy teaches us a different lesson. It teaches us that answers are often just temporary shelters. They are small warm rooms we build in a dark, infinite and wondrously strange mansion. And for every answer we find, we discover 10 new doors leading to 10 new hallways we never knew existed. A wise person once said that philosophy is not about finding the right answers, but about daring to take refuge in the question. To take refuge is a beautiful phrase. It implies safety, comfort and peace. It suggests that we can stop running. It suggests that we can find our home not in the solid, unmoving truth, but in the dynamic, living, breathing mystery. This is the meaning of our search. The meaning is not a final, static answer. The meaning is the act of questioning. It is the courage to look into the void and not be consumed by fear, but to be filled with wonder. The universe in all its vastness does not give us meaning. It gives us the raw material to create it. This brings us to this great paradox of our existence, the coexistence of our smallness and our greatness. Let us be honest about our smallness. On the cosmic scale, we are almost nothing. We are a brief, fragile flicker of consciousness on a single tiny planet orbiting an average star, tucked away in a quiet corner of one galaxy, among billions. The laws of physics, gravity, time, and the slow, inevitable march of entropy are completely indifferent to our hopes, our dreams, and our sorrows. The universe was here long before us, and it will be here long after we are gone. We are a statistical impossibility, a rounding error in the grand equation. And yet, in the very same breath, we are magnificent. We are the universe itself woken up. We are the cosmos become self-aware. We are a collection of stardust, the carbon in our skin, the iron in our blood, the calcium in our bones, all forged in the hearts of exploding stars billions of years ago. We are not separate from the universe looking in. We are the universe looking out. We are the only part of this vast system, as far as we know, that can comprehend its own beauty. The rings of Saturn do not know they are beautiful. A nebula does not marvel at its own colours. A black hole does not ponder the nature of its own gravity. But we do. Our smallness is a fact, but our greatness is a choice. We are small in body, but we are infinite in mind. We are the part of the cosmos that can write poetry, that can compose music, that can build telescopes to look back at its own origins. This is the miracle. We are simultaneously a speck of dust and the mind that can comprehend the dust, the stars, and the space between them. If this is true, what then is the point? If the universe does not provide a purpose, what is the meaning of our brief, passionate lives? The meaning is in the reach. The meaning is not the destination, but the journey. The meaning is not the treasure, but the search. The reach matters. Meaning is not something you find as if it were a lost object. It is something you build every single day. It is the scientist who spends a lifetime studying a single distant star, knowing they will never visit it, but driven by the pure desire to know. It is the artist who tries to paint the colour of the sky at sunset, knowing they will never truly capture its perfection, but is changed by the effort. It is the parent who reads a story to a child, passing on the spark of curiosity and connection. The universe doesn't care if we are kind, if we are curious, or if we create beauty, but we care, and in that caring we invent meaning. We create purpose. Our reach for understanding, our reach for connection, our reach for something more that is the meaning. The universe is a silent blank canvas, and we are the artists. We are the echo. The Big Bang was the first word, a single universe-shattering vibration. For nearly 14 billion years, that sound has been expanding, cooling, and spreading out. The stars, the galaxies, the planets, they are the physical resonance of that first sound. And we are the part of that vibration that has finally, after all this time, curled back on itself and learned to listen. We are the echo of that first word, our science, our music, our philosophy, and all our questions. This is the universe hearing its own voice. When we ask, why? We are the echo asking about the original sound. And so here at the end of our time together we find a gentle peace. The universe does not need us, but we for this brief, brilliant moment have the profound privilege of needing it. We need its beauty, we need its mystery, we need its vastness to give us perspective. The very act of you listening to this, of taking this journey through time and space in your mind, perhaps as you lie in the dark ready for sleep, that action is itself a part of the great search. It is your act of reaching. It is you being the echo. Now it is time to rest. Let the large questions fade. Let the silence of the cosmos, the silence that existed before the stars and the silence that will remain after, hold you. You are a part of it. You are not a stranger here. You are home. Sleep well and good night.